Precipitation hits the Earth's surface by mandate of nature. Then it follows two paths. One path returns the water to the atmosphere as evaporation and transpiration. The other path returns the water to the ocean as runoff by flowing on the surface and subsurface, subject to gravitational forces. On a global annual basis, about 2/3 of the precipitation returns to the atmosphere. The remaining 1/3 goes on to constitute runoff. Nature would not have done it otherwise and still follow basic laws. If all the precipitation is converted to runoff, there is no water left to sustain the vegetation. Conversely, if all the precipitation is converted to evaporation and transpiration, there is no water left to carry the solids to the ocean. Under this last scenario, the natural process of weathering would eventually accumulate salts on the land without limit, increasing the number and size of deserts. Instead, nature intended for there to be a balance. Globally, 2/3 of water for the plants, the remaining 1/3 to flush the solids to the ocean. The ratios vary as a function of climate, geology, geomorphology, and relative continental location. Peripheral continental regions are usually exorheic and thus are generally able to drain their salts effectively and remain largely free of salt accumulations. Non-peripheral continental regions are sometimes endorheic, that is, they have zero outflow. Unable to drain their salts, these endorheic drainages are plagued with salt accumulations over time. Once salts move in, they discourage diverse ecosystem growth, effectively contributing to the development of deserts. Enter humans and contemporary human society. A sizable fraction of the available water having already been committed to the plant kingdom, we are free to tap only the remaining fraction, that is, the runoff. More often than not, however, we forget that the runoff has already been committed by nature to carry the solids to the ocean, that is, to flush the land of its salts. This leads to the ill-advised practice of sequestering all the runoff, presumably for economic use. The often convincing argument is that we should not waste a drop of water, because water is precious. Common sense, however, should point otherwise. If we succeed in sequestering all the runoff, we would also be sequestering all the solids. This, of course, is counterproductive because it is unsustainable. A peripheral continental basin which fails to remain in salt balance will eventually degrade to the point where it mimics salt-infested endorheic basins, which are naturally out of salt balance. A sensible course of action is to reserve a portion of the runoff to carry the salts to the sea. This important decision has to be done with attention to conflicting societal interests. A carefully calculated salt balance will determine whether a peripheral continental basin, subject to anthropogenic alteration, is likely to remain sustainable. A classic example of a major watershed striving to remain in salt balance is that of the Santa Ana watershed in San Bernardino, Riverside, and Orange counties, California. One thing is patently clear: sequestering and consuming all runoff is unsustainable unless we are prepared to painstakingly cart the salts away to the ocean by means other than gravity. Yet, increasing our carbon footprint in the process of effecting salt removal is not sustainable either. Therefore, we must reserve a portion of the runoff to perform this most crucial natural service.